Okay, this video is for homework 1 for controls class. I'll be going over problem 17, which is as shown right here. I think to solve this problem, the easier method to do would be using Bernoulli's method. To solve using Bernoulli's, we gotta know what n is for this problem, or this equation. And n is 2. How do we know n is 2? We know n is 2 because the power of y is 2. Once we have determined that that's what n is, looking at this equation, we'll put it into the standard form. To do that, take this xy onto the other side, and you would have negative x4 times y squared. And we want to get rid of this x, so let's just divide everything by x. So when you do that, you would have dy dx minus 3 times y over x equals negative x cubed times y squared. Now it's x cubed because we divided x with this term, and since there's an x over here, we know that the power of 4 would become 3. Once you have put into the standard form, we'll substitute for v equals y to the 1 minus n, which is a part of using Bernoulli's. So when we do this, simply substitute the value for n over here, and you would be left with y to the minus 1. Then you would have to take the derivative of this, and when you differentiate it, you would be left with y to the minus second, or you can write that as 1 over y squared, and because of the negative, there would be a negative in front. And of course, this is to the respect of y over x. Once you have this, you would take this term and multiply it with our standard form term that we have right here. And that will leave you with negative 1 over y squared dy dx minus 3 times negative 1 over y squared times y over x equals x to the third times negative 1 over y squared times y squared. So looking at the equation, we can see that we can simplify it a little bit more. So we have y and y squared here, and we can reduce the power of this to y to the 1. That's y to the 1. And we know there's y squared here, so cancel that out. And we would have it to negative 1 over y squared dy dx plus 3 over x times 1 over y equals x cubed. Once you have this, we would have to substitute the equation for v of x, because we're trying to find p of x and q of x for this equation, so we can solve it using first order linear equation, which is right there. So when you do that, you will have dv over dx plus 3 over x, which is our p of x times v, equals x cubed. And we take that and we're going to use that to solve using first order linear equations. This is an equation that you should know, which is u of x is equal e to the power in which we would use the integral for p of x. And we know earlier from what we were discussing that p of x is this term right here. So we take that and integrate it, and we would get 3 times natural log of x. And this is e to the 3 natural log of x. And from the properties of natural log, we know if there is a coefficient before natural log, it becomes the power of the variable that is the absolute value, which would make this x cubed. Once we know what this is, then we can multiply this by the equation of ux to our equation that we had earlier. So this would give us dv dx times x cubed plus 3x v squared equals to x to the 6th. This becomes x to the 6th because x times x to the third times x to the third. You have two similar terms and the powers add up and it gives you x to the 6. So to do this, you would have to integrate it, or reversing the product rule for this, and you would have d over dt x cubed v equals x to the 6. So when you integrate it, x to the third to the v dx equals x to the 6 dx, you would be left with x to the third v equals x to the 7th over 7 plus c. So we would have to solve for v of x now, and to do that, we would have for this similar expression, you would have to take the least common multiple. So we have 7 x over 4 to the 7 and the constant over the x cubed. So that would become 7x cubed, and when you take the least common multiple, this would become x to the 7 plus 7c. And then we take this equation and substitute for y, and to get our final result, which is 1 over vx. And since if you put v of x in the denominator, because this is in the denominator over here, so this would be reciprocal, and this would go into the numerator, and this would become numerator 7x cubed, x to the 7 plus c. I think it's better to write the expression as just c, because we know that 7 times a constant is a constant, so if we just leave it in this form, I think it looks better. Pretty much that's how you solve this problem. Thank you.